The moment of inertia of a solid sphere is 2 over 5 mr squared, where m is the mass of the sphere and r is the radius. A shows that the total kinetic energy of the sphere when it rolls without slipping at speed v is 7 over 10 mv squared over 2. So when an object is rolling, there will be kinetic energy which consists of two kinetic energies. It's translational and rotational. It's translational due to overall motion with speed 0.5 meters per second. It's our usual kinetic energy, which is what just mv squared over 2. But since it is rolling, there will be what? Rotational kinetic energy, and formula is given in a data booklet, and it's I, it's a moment of inertia, angular speed squared over 2. And we need just to get that it is equal to this, and you can see we need get rid of omega to rewrite it in terms of usual, or it's called linear speed, and we know that omega is what? It's, and actually we can substitute expression for I. So omega is what? It's v over radius squared, and I is just what? 2 over 5 mr squared, and you can see that r squared cancels, and we get what? mv squared over 2 plus 2 over 5 mv squared, and what? Just common denominator, which is 10, so it's 5 plus 2, it's 7 mv squared over 10 as required. The next, a solid sphere of mass 1.5 kilograms is rolling on the horizontal surface with a speed 0.5. The sphere then rolls without slipping down the ramp to reach a horizontal surface that is 45 centimeters lower. Calculate the speed of the sphere at the bottom of the ramp, and you may deduce that we can just apply what? A law conservation of energy. You can see that there is a difference in height. So at the top, since it is rolling, there will be what? Kinetic energy, which consists of translational and rotational, or we can use the obtained expression. So it's 7 mv squared over 10, and plus gravitational potential, and formula is mgh, is transferred into kinetic, but it will be rolling at the bottom, so it will be also kinetic energy, only kinetic, because we take this to be the ground level, so height for at the bottom will be 0. I hope it's clear. And again, it will be the kinetic, which consists of rotational and translational, but you may use again the same expression, because this expression is always true when a solid sphere is rolling. It doesn't matter where it is rolling, because if you consider again the sum of translational and rotational kinetic energies, you will get absolutely the same result. So it becomes mv 7 mv primed. It's another v which should be found over 10, and we need just solve for this v primed. You can see that m cancels, we can multiply by 10. Oh, actually it doesn't matter, so it becomes 7 times v is what? 0.5 squared, 0.25, and plus 9.81 times 0.5. Notice that it must be in meters, and it is given in centimeters, and we multiply everything by 10, so times 10, and you can see it becomes 7 v prime squared. So we divide by 7, or actually we can divide by 7 and then square root to get v prime. And let's just calculate it. So it becomes 0.25 plus 9.81 times 4.5 divided by 7, and then square root of the answer, and it's 2.56 meters per second. But since we can see that everything is given to two significant figures, for you remember that for multiplication or division, keep such number of significant figures as least precise, so it's reasonable to round it to 2.6 meters per second. And that's all for this question.